Have you ever heard of the Goldbach Conjecture? It's one of the most renowned unresolved problems in mathematics. This intriguing enigma was first formulated in 1742 by a Prussian mathematician named Christian Goldbach. Now, if you're wondering what this conjecture is about, allow me to simplify it for you. Goldbach's conjecture states that every even number greater than 2 can be expressed as the sum of two prime numbers. Now, prime numbers are those special numbers that have only two distinct positive divisors, 1 and the number itself. So, when Goldbach says every even number greater than 2, he means numbers like 4, 6, 8, and so on. And his conjecture suggests that these can be broken down into a sum of two primes. So every even number greater than 2, according to Goldbach, can be broken down into two prime numbers. Intriguing, isn't it? To better comprehend this conjecture, consider a few examples. Let's delve into the world of even numbers and prime numbers. Take the number 4. It's an even number, right? Now, can we express it as the sum of two prime numbers? Indeed, we can. The prime number 2, when added to itself, gives us 4. So, we have 4 expressed as 2 plus 2. Next, let's take a look at the number 6. It's also an even number. Can we express it as the sum of two prime numbers? Yes, we can. The prime number 3, when added to itself, gives us 6. So we have 6 expressed as 3 plus 3. Moving along, let's examine the number 8. It's an even number as well. Can we express it as the sum of two prime numbers? Absolutely. The prime numbers 3 and 5, when added together, give us 8. So we have 8 expressed as 3 plus 5. So what are we seeing here? In each of these examples, we're able to express an even number as the sum of two prime numbers. 2, 3, and 5, they're all prime numbers. And 4, 6, and 8, they're all even numbers. As we can see, the Goldbach conjecture holds true for these examples. But does it work for all even numbers greater than 2? Since its formulation over 2 centuries ago, the Goldbach conjecture has been exhaustively tested for gigantic even numbers. Let's dive into the mystery surrounding this conjecture. The Goldbach conjecture has been put to the test time and time again, with mathematicians painstakingly verifying its validity for increasingly large even numbers. From the number 4 right up to 4 quintillion, that's a 4 followed by 18 zeros, the conjecture has held. Each and every one of these colossal even numbers has been shown to be expressible as the sum of two prime numbers, just as Goldbach predicted. But here's where things get intriguing. Despite all these successful tests, a general proof that applies to all even numbers greater than 2 remains elusive. Yes, you heard it right. Mathematicians, with all their combined intellect and ingenuity, have yet to find a definitive universal proof that confirms Goldbach's claim for every single even number. The search for this proof is not for lack of trying. Countless hours, days, years have been spent wrestling with this conjecture, attempting to either prove it universally or find a counterexample that disproves it. Yet all efforts have so far been in vain. So, while the Goldbach conjecture stands as a fascinating mathematical proposition, its definitive proof remains one of the greatest unsolved mysteries in the field of mathematics. This, my friends, is the enigma that is the Goldbach conjecture. Did you know that proving the Goldbach conjecture could make you a millionaire? Yes, you heard it right. In the year 2000, Faber and Faber, the publishers of the novel Uncle Petros and Goldbach's Conjecture, put forth a challenge that would change the course of mathematical history. They offered a staggering prize of $1 million to whoever could provide a general proof for the Goldbach Conjecture within 2 years of the book's publication. The challenge was audacious, the stakes were high, and the world of mathematics held its breath. Yet 2 decades later, the prize remains unclaimed. Despite the tantalizing monetary incentive, the Goldbach conjecture continues to elude even the brightest mathematical minds. Its proof just as elusive as it was over 250 years ago. So if you're good with numbers and fancy yourself a bit of a mathematical sleuth, you might just have what it takes to crack this centuries-old enigma. Who knows, you might just become a millionaire.